class, and welcome to lesson 3.3, adding vectors. I believe I owe you an apology. I believe last lesson, I can't quite remember, but I think I said we had a quiz. However, I forgot to remember that I forgot to add. We have to add and subtract vectors before we can have that quiz. So I apologize for that panic or that extra review that you may have been caused. However, it'll just be getting you ready for in 3 classes time or 3 days time when we do have the quiz. So I apologize for that early warning and incorrect date on that, but it will follow. The quiz will follow after we've done our adding and subtracting of vectors. All right, let's take a look at lesson 3.3, adding vectors. And this is what we call vector resultants. So the sum of vectors is called the resultant. If we draw vectors and add them together, we can use our ruler to measure the resultant after that. Okay, so there's 2 ways you can measure it. The first way is doing what we call a tip to tail, placing them together. Okay, so if we have 2 vectors, vector u and vector v, notice what's happened in order to do u plus v is you've gone from the tip of one to the tail of the other. So notice that's the tip to tail method. And then the resultant is the red dashed line. So basically I've got my resultant here. Let's just see how quickly I can then measure it. Sorry, my ruler's lagging a bit. Oops, grabbing the wrong thing. Okay. So I can take a look, and once oops, sorry, come on, ruler, work with me. Sorry, sometimes this ruler, although it's really cool when it works. Let's see if, stop there, please work. Oh, need to bring it down. Oh, let's back that up. Sorry, guys, give me a second. It was easier where I had it backed up without the angle. All right, so taking a look, it's roughly 7 centimeters there. Okay, guys? All right. So you can do the tip to tail method where you take the tip of one and put the tail on the other. And then again, the resultant is going to be our dashed line here in the red in this case. Okay. The second way you can do it, and the least common, I would say the most common is the first one, is most common. But another way you could do it is forming a parallelogram, then placing them tail to tail. Okay. So what you do is if you've got vector u and you want to create a parallelogram, you put them tail to tail, and then you create a parallelogram with them. All right. And when you then have a parallelogram, you have to go from the start, which is the tail to the tail, to the tip to the tip. Okay. And notice, folks, that that is the same line. Let's see if this works for me, guys. Let me see if I can move it quickly. Notice, guys, that it's the same line depending on which method you want to use, and hopefully it'll come right back in here nicely for me. My smartboard will cooperate. I think that's right there. Okay, good. All right. So to add parallel vectors of the same direction, you note that they will be the same. Okay, so the difference between the first ones and parallel vectors is, notice that the direction is the same. Okay, so parallel vectors have the same direction. Which it says right there. All right, so if we have vector A and vector B, and we want to add them together, you will notice that vector A plus vector B equals vector B plus vector A. So what I could simply do, hopefully this works, is take B, my smartboard would cooperate. Oh, it's very touchy today. Okay, and I take vector A. Okay, so I could do A plus B or B plus A because the direction is going to be the same. Okay, let me see if I can move these back now. All right, good. Okay, now to add parallel vectors of the opposite direction, okay, you notice that you were going to have the difference in them, okay? So take a look if you're adding the opposite direction, okay, that you're going to have a diagram like this. Okay. So if I have A, oopsie, 1 second, I think it's, let me have to ungroup it for a second. Okay. So if I have A and I'm adding B, notice there, my fault. If I have A and I'm adding B, okay, the resultant, which is in red, my fault, the resultant, which is in red, is our difference, okay? So that's what that is, A plus B. All right, so opposite directions, again, I'm sorry, opposite direction is just going to cancel each other out. So it's basically like you're adding a negative. All right, let's take a look at our second sheet. All right, vector equivalents. These are just like our regular diagrams, but in vector notation. So in the square ABCD with center E, what do we note first of all? That AE plus EC equals AE. That makes sense, right? Because they're going in the same direction and they have equal magnitude. Okay? All right. What is the vector equivalent of AD plus DB? Let's try that. So if we go AD plus DB, okay, our resultant in this case, folks, would be from here to here. So what does that tell us? That's got to equal vector A, B. Okay, let's take two other ones that might be equivalent. Okay, so AE plus ED. So let's focus on those two for a second. So AE plus ED. Again, our resultant will be AD. Okay, let's do one more here. Change color. So if I have DC, so D to C, okay, plus C to B. I'm going to go trickier here. Plus B to A. Okay, what does that equal, guys? Well, where we started to where we end is our resultant, so that's going to equal DA. And remember, it's got to be in that order. It can't be AD, otherwise that's the opposite direction. Okay, let's do a little recall here, guys, between the difference between displacement and distance, just like you did on your worksheet. Okay, remember that distance is a scalar quantity because it only has a magnitude, but displacement is a vector quantity because it has a direction as well. If Claire walked the path shown, the distance walked would be about 13 meters. So let's take a look at that. Distance equals 2 plus 3 plus 4 plus 4. Okay, so that's going to equal 13 meters. Okay, whereas her displacement is all of the in the direction where we're going, it's the resultant. So we start here, which is at 2, and we're going to end here. So it's going to be 2 plus 5 plus 4, which equals 11 meters. Okay, and if you weren't given this, ladies and gentlemen, hopefully you recognize this as a special triangle. It's called the 3, 4, 5 triangle. It's one of those special triangles hopefully you remember. If not, there's a recap of it. All right, so ladies and gentlemen, that's adding vectors. Again, you can do the tail to tip method or you can create the parallelogram. And remember that direction is important with these vector quantities. Okay, here's your homework, page 52 and 53, numbers 1AB, 2, 6, 8, 9, 11. And again, come see me if you need extra help. Have a great day.